Hey everyone, I'm Paul Ramsey. I'm an open source developer working for Crunchy Data, primarily on PostGIS and Postgres, but also on some related projects I want to tell you about today, PG tileserv and PG featureserv. Now, before I get to the specific features of tileserv and featureserv, I want to give you the motivation behind the projects, like why did we even start building them in the first place? I also want to be clear about what these projects are and what they aren't. What they are is small pieces of functionality that we think web developers will find useful when building web applications that use PostGIS. They aren't applications in and of themselves, they're parts, which can be assembled by web developers into a larger whole. So web developers, clever people with lots of technical smarts, will be building a web application. And then inevitably, some part of the solution will require a map, or it will have to answer a question that involves location or a context, or it'll have to calculate a result that takes in geographical inputs. And all too often, particularly if they're new to the field of geospatial or mapping, or if they're just smart people used to solving problems with web tech, they'll get told that there's a whole big product category that does what they want. They'll need a spatial middleware, or maybe they'll need to sign up for a specialized spatial web service, or they'll need to purchase a bunch of base map data. And the whole thing will turn into a depressing rat hole of learning about a completely new ecosystem of software when really all they wanted was a map or an answer or a calculation. And here's the thing, web applications are almost always built around databases. Postgres is the most popular cloud database around, and Postgres has PostGIS as an extension, which has all the smarts of a GIS. Really, PostGIS is GIS without the GIS. No distracting GUI, no plotter paper, no digitizing, just clean, beautiful SQL answering spatial questions. What parcels are within a kilometer of the fire? Like, this is a stereotypical GIS question. I can even draw a map about it, but I don't need a GIS to get the answer. The answer takes just a tiny snippet of spatial SQL. How far did the bus travel last week? Also, a classic location services question. You can put it on a map, and you can get the answer with just a tiny snippet of spatial SQL. What trucks are in the service depots? This is great. It's a multi-layer question. It involves trucks and service depots. A GIS user might call it a filter by layer operation, but we're clever SQL database people, so we know that it's really just a 5-line spatial join in SQL. So PostGIS and Postgres give us the SQL engine and the spatial types, the functions, the indexes we need to get all the analytical and data management functionality of a GIS without the GIS. We can do spatial things in our applications without having to add more complicated software. And at this point, the web developers at home might be thinking that this sounds like the greatest thing since sliced bread, that it's time to get a piece of PostGIS and start working with it. So how do we add all this PostGIS goodness to our web applications? And the answer is, well, you connect to the database and send it a query, which is, well, that's a problem. Web applications don't connect to the database. They connect to web servers. All that JavaScript and HTML goodness on the client side, it has an expectation that it talks to an HTTP web server. Local applications like QGIS on the desktop or PGMN, they can connect directly to a database on port 5432. But web applications, they need to connect on port 80 or port 443 for secure sockets. And they don't speak the Postgres line protocol, they speak HTTP. So there needs to be something in between the database and the application. Now, traditionally, that thing in the middle, it's called middleware. It's written in a language like Java or Python or Ruby, and it's specific to the application. But we know something about web mapping applications ahead of time. This is not a sui generis thing. This is something we know about. They have a particular structure. We know that web maps like to consume spatial data as vector tiles or as GeoJSON. So they like services that take in HTTP requests for tiles or features and return results in these formats. And we know that PostGIS has built-in functions, STAS MVT and STAS GeoJSON, that can generate these functions efficiently inside the database. So the layer in between the web mapping application and the database doesn't have to be super complex. It just has to take in standardized web map requests and convert them to SQL to run in the database. Now, the first time someone asked me about vector tiles in the database, I figured I would just write up an example middleware. So I did that, and it took about 100 lines of Python. I mean, really, there's just not a lot to it. The script revolves around the tile addresses can be converted to a query envelope, which pulls back a geometry column and some attributes for the bounding box, which are then all converted to an MVT output format and sent back to the web client. The whole thing boils down to just this little query. And the blog post around this ended up being really popular. So we started asking ourselves at Crunchy, maybe rather than having everyone write this script up in all the different languages, we could make something for them that could skip this step. Because deploying Python web applications can be easy or hard depending on how Pythonic you are. And the same things tends to be true in a lot of these interpreted languages. We were looking at the way that Postgres is being deployed, which is increasingly as containers, and the work in Kubernetes and the containerized Postgres work that our teams are doing. We wanted to make some pieces that were small, because smallness has a bunch of useful characteristics. It makes for an architectural piece that's easy to take or leave. If you deploy it, it's because it does the thing you want. It doesn't do a bunch of things you don't want. If it's small, then new contributors, new open source contributors, don't have a huge ramp-up time to figure out the structure and contribute. They can just dive right in. If it's small, any bug or issue will be easier to find. If it's small and stateless, it makes a perfect unit of computation to package up in a container for cloud deployment. So again, we come back to Kubernetes and the new way of the world. So we made a long list of all these small units of functionality that we wanted to build. We decided we would call them PostGIS FTW, PostGIS for the win, or PostGIS for the web, that would make it easier for app developers to add spatial features to their sites by making use of all the spatial functionality that resides in the database they're already using. And the first two pieces we decided to build are PG tileserv and PG featureserv. Tile and feature servers. They're very similar pieces, and it went back and forth multiple times on whether to simply have one service that provided both formats. But in the end, we settled on two because we get two smaller features, smaller pieces of software now, and we can always change our mind on that later. And note they do very similar things. On the database side, they take tables and functions in the database, and they make them visible to the outside world as HTTP endpoints. They're returning either tiles or GeoJSON features. So they have quite different outputs, tile and feature collections, but they work with very similar inputs, tiles or tables and functions. So publishing tables is the easy bit. If a table exists in the database and it can be published, it is published. So the service, whether the feature service or the tile service, it connects to the database with a database login. And if that database account has read privileges on a table, it gets published. And here you can see the default paths the table would show up on. For tiles, the root is the schema and the table name, and then you get the desired tile coordinates that the client will send in. For the feature server, for GeoJSON, the root is a collections directory, then we get the schema and table name again, and then we get the items to get the particular items back out. Both servers, that's sort of like the basic. You call that endpoint, you get back a view of the whole table. But both servers have some extra options to change how a table view comes back. The tile server, that's the simplest one, it has 4 options. The properties option allows you to subset the columns returned in tiles. So a vector tile includes both the shapes and the attributes of all the features in the tile. So a really wide table with lots of attributes with lots of columns, you might only want to send back the attributes you're using in your application. That makes the tile smaller and faster. There's also a limit option to change the maximum number of features per tile, and there's some rendering options to change the default resolution, the amount of extra buffer space around each tile the server sends back. These are kind of hard to explain without lots of pictures and details about vector tile rendering, so I'll skip them for now. The feature server has more useful options. The bbox option allows you to limit the features returned by box. That's very handy because you rarely want the whole table sent back. You can also limit by attribute value. Now, just like the tile server, you can reduce the attributes you send back using the properties option. And then you can use the limit and offset options to carry out paging on a data set. So limit forward to the start of your page, offset to forward to the start of your page, then limit the number of things you want on that page. You can also order the results by an attribute. And you can kind of see where this whole thing leads, with lots of fancy logic, migrating to filters, being sent back in the URL. So we've only got a few of these things so far. The layout of the collections and so on in the feature server was guided by the OGC API for features. This is still an evolving specification, but the whole thing is based on OpenAPI So there's an API Explorer based on that. And in theory, this makes it quite easy to integrate with other web services tooling. So now you might have noticed that I promised you GIS without the GIS over the web. And so far, all I've shown you is a tile service for tables and a feature service for tables with a few very limited filtering options. So this is a big letdown so far. But we've only talked about tables so far. We haven't talked about functions. So as I mentioned earlier, both tileserv and featureserv can publish not only tables, but also functions, and that's where the power is. Because as long as you can wrap up your spatial query logic in a function, you can publish it out to the web to be consumed by a web application. So here's how it works. In tileserv, if you define a function that takes in an x, a y, and z integer parameters, that is to say the components of a tile address, and then any other parameters you like, and that function returns a byte A type, it will be published in HTTP under the schema and function name with the usual tile path. And then after that, you can add in the other parameters. So you can now have parameterized tile generation. Now, unfortunately, that means you have to generate tiles in your function, which makes the functions quite large and ugly, as we'll see. But it works. In featureserv, the functions are much simpler and a lot more powerful. The function signature can be anything, as long as it uses named parameters, because the named parameters are then used in the HTTP signature. And the return value for the function can also be any table-valued return, which again means you have to define column names and types, which are then used in the JSON output return values. So a function that can take in and return anything can be published to the web using featureserv. You can see any parameter you ask for, then it gets published out as part of the HTTP signature that you query on. So here's a couple examples. First, a tile generating function. It's like, oh, it's really big and huge, but we'll only show this one. We'll actually show this one in the demo. So note at the top, we've got the parameters. We have an x, y, and z integer parameters. That determines what tile we're going to pull. In this case, we've added one extra parameter, a name prefix parameter, which we use to filter the countries table. And the tile generating SQL is just like the SQL from my Python script I showed earlier. It figures out the bounds using the tile coordinates, and then it applies those bounds to filter the geometry. Then it also applies, you can see down lower, the name prefix parameter value as a filter in the where clause. So this function just applies a client-supplied filter parameter to the tile generation. But a tile generator can create anything as long as it's a tile, and I'll show you some of these more fancy tile generators in the demo. The featureserv function is way simpler because it doesn't have to generate tiles. It just has to generate an output table, an output tuple set. So note that featureserv only publishes functions it finds in the PostGIS FTW schema. It's because featureserv is so flexible in the kinds of functions it accepts that if we published all functions that it accepts, we'd probably end up accidentally publishing a bunch of functions we didn't mean to. For tiles, we don't have this restriction because the tile function signature is quite unique. But the feature function signature is basically, give me anything and I will return anything. So we need the restriction. This function here, this example, does the same thing as the tile function actually that we just showed. It takes in a name prefix and filters the countries table. But it doesn't have to form a tile output, so it ends up looking a lot simpler. All it's running is a query in the countries table with the extra filter prefix appended to the where clause. Okay, so now we have all the parts we need to build a little web application using tileserv and featureserv. We can use the basic functionality to publish layers. We can use the advanced functionality to run SQL analytical functions in the back end and get back computed results that we can show in our web front end. So for this demo, I'm going to load some simple data into my database, and then I'll turn on tileserv and featureserv. We'll do a little bit of exploration using the existing admin UI. And then I'll bind together the services with some custom functions and an HTML JavaScript page to show off GIS without the GIS in action in a small point-to-point routing app. Okay, it's demo time. I'm going to be building a small point-to-point routing demo. I'm going to be using PostGIS database, tileserv and featureserv, and a little web app. Here's the web app. It's not running yet because we haven't set up the database and the tileserv or the featureserv yet, but once those are up and running, I'll show you how it works. So what have I got here? I got my trusty web browser with a few useful tabs open. I've got a few handy terminals open. I've downloaded a little bit of data ahead of time, but I'll be setting up a bunch of stuff from scratch. So I've got some country boundaries, some OpenStreetMap data from Boston downloaded already. I've got a little bit of example sample code I'll be using, some SQL functions to demonstrate, and then the source code for the web app itself, the HTML JavaScript source code. And that's about it. So, nothing up the sleeves, nothing behind my back. This is pretty much a from scratch demo. So let's start off with the database server. I'm using a database running on the Database as a Service offering, Crunchy Bridge, from us good folks at Crunchy Data. I've chosen a relatively small database here. I think this is a medium size, the second size up or the first size up from the very smallest thing. Right now it's got no utilization because I've loaded nothing into it. I'm going to copy our connection string here, connection credentials, and start off by connecting to the database. All I'm going to do is stick this connection string into the database URL environment variable. This is the same URL that the tileserv and the featureserv use for their connections. And once I've got it set in, PSQL is happy to read database URLs. Now I'm connected. Blank database, nothing in there. I'm going to create PostGIS because that's what we need for our good spatial stuff. Create extension PostGIS, boom, and check our version. Make sure we got good stuff here. Yes, we do got very good stuff here. This is one of the things I like about Crunchy Bridge is we make sure that our packages are very up to date. Even packages of things like extensions, PostGIS, so the 3.0.1, that's the latest stable release stable branch. GIS 3.8.1, latest stable release stable branch. So we got nice fresh software. We're also going to be doing some routing. So let's add the PG routing extension. Boom, PG routing installed. So our database is pretty good to go. So what we need now is to get our hands on a tile server. So let's get a tile server here. I'm going to go right from scratch and go to GitHub. So here is the GitHub page for PG tileserv. What do we got? We got a bunch of source code. Little thing to notice here. So this is Go. We chose to write tileserv and featureserv in Go. Because it's a lovely server-side language, because it is multi-platform, but it does compile down to native. And the native binaries it compiles are complete. They bundle in all their dependencies. So when you install a Go application, you don't have to install a whole bunch of dependencies. The application itself includes all the dependencies. This makes it a really simple install, as I'm about to show you. We've got binary builds for Linux, Windows, OS X, Docker images as well. So I'm going to pull the Linux. Let's see, copy link location. I'm going to pull the Linux build, and we'll do this over here. Download it, zoom, make a directory for it, go into the directory, and then we'll unzip the package. And this is everything that's inside the package. So what do we got in here? We've got a binary. Here it is, PG tileserv. We've got some configuration files, which I think I'm going to leave untouched. Actually, no, I'm going to change them a little bit. So I'm going to go and do one change to the default configuration. And remember this from when I was testing out this demo, which is that the default number of features per tile is just a smidge small for the data that we're showing. So right now we're maxing out at 10,000, so I'll just bump that up to 100,000 features per tile. That's still, I mean, it's a lot, but it's still small enough that they can be rendered in, a couple seconds, which is not bad for spitting back tiles with 100,000 things in them. Okay, so we got our binary. We're ready to run. All we need to do is supply it with a connection string. So I'm going to go back here and get my database URL and stick it into this one. So now I'm set up. So that's the connection string. It's in the database URL, and I'm going to tell tileserv to run, and it'll say, well, how should I connect? Oh, there's a database URL. I'll use that. And now we're all connected up. We can see we're running on port 7800 on my server, so I'm just going to pop over to the trusty web browser, go to the tile server page pointing to port 7800, give it a refresh. Tileserv is running live. Okay, we're up and running. Notice that blank database, so we've got no table layers, we've got no function layers. Both tileserv and featureserv are built to be machine accessible. So we've got this human accessible web page at the front end. If you ask for index.html, this is what you see. If you ask for index.json, if you're a computer, it'll give you the service metadata, which actually is really boring right now. It's just an empty list, so it's not rendering anything. Let's load up a table so we can see what's going on. So next we've got a table handy. As I said, we have some natural earth data, so let's go in there and convert that. So we'll use shaped PGSQL 4326 spatial reference system, and we'll pipe that to our database connection, and boom, we're all loaded up. There's 241 countries from natural earth data loaded in. If we go back to our tile server and refresh it, there it is. So now if we go and look at the service metadata, you see actually we have something. Oh look, we've got one table loaded, and here's the information. This is all in JSON. So we can even go a little deeper in. So for each table, we got a detail URL. If we click into that, it will give us some more information, and we can all see all the things about this table. Here's properties. So every column has a type and a name, and this natural earth data is really wide, 25, 35, 40, 50, 60, 70, oh my god, 84, 91, 94 columns, and then the bounds, which is pretty much the whole world, and then the URL you use to connect to get vector tiles. And that's kind of the important thing. You can see all this service metadata is there, so you could actually make a self-configuring app that just looks at the service metadata and configures itself. And in fact, that's what we've done here in this human interface, the tile server. This is basically a way to browse the data that you've got. One thing you can do is to look at the service JSON, but you can also just look at a preview page. And all the HTML in this preview page does is read that self-describing metadata and use it to construct a map and pull that data back. So here's all the countries which we loaded. Loaded as tiles. We can zoom in. Everything's nice and fast because it's just vectors. Because it's vectors, you've got, in addition to the shape, also all that attribute data. You can see here's the 100 attribute names we're pulling back. If I actually click on an object, you can see the at least some of the different attributes, the names in different languages, names in Korean, and I don't even know what that language is. All right, so we've got our test layer loaded. We've seen it in tileserv. So let's look at the same thing in featureserv. So same story as with tileserv. I'm going to start over here at GitHub. Crunchy Data PG featureserv this time. Again, it's all written in Go. Again, the idea is to provide HTTP service on top of the database. In addition to just sort of providing the service, we're following the OGC API feature standards. That means we follow some of the basics of the standard, like limits and bboxes. Also have a few extensions that are specific to Postgres. And let's see, oh, here's our download, so I can get my Linux build. And I'll copy that link location, go back to my handy terminal, and we'll put that in this one. There's featureserv. We'll give it a directory to work from. And we'll unzip the binaries. Boom, we're up and running with featureserv. We're all set. Next trick is, right, I just need the connection string again. So I'll grab the connection string for the terminal, plug it in here, and now PG featureserv has everything that it needs in order to get started. So boom, we're up and running with PG featureserv connected to the same database. That's pretty awesome. Let's go have a quick look at the PG featureserv UI. So it's the same idea. This is a UI for browsing. This is not something you'd ever show to end users. It's just for the purposes of taking a look at your data. So I'm going to refresh this page. Here's the front page of PG featureserv. We have one collection now because we've loaded the country's data, so it shows up automatically because we're connecting with a user that can read from that table. We see that table by default as soon as we connect. We can look at the data in JSON form, or in on a map. There's a JSON form. Again, we can see we've got a table name going on here. Geometry type now because we're dealing with GeoJSON. Same properties as we saw in the tile because it's 80 columns wide. And I think that's about it. Oh, and we can link in deeper and take a look at things item by item, for example, or look at the HTML summary. Instead, I'm going to go have a quick look at the map view of the data. And first thing you'll notice here is that, hey, wait a minute, there's not very many features here. What's going on? There's supposed to be 269 countries. Why am I seeing 10? The answer is in order to avoid clogging people who accidentally request the JSON endpoint and sending them back 100,000 things, featureserv is set with a very, very small feature limit by default, I think 10. So I'm going to pop it up to 500 and require it. So then we'll get all of the countries in GeoJSON. Here they are. Hello, all your countries. They look very much like the ones we saw on the tile server. The only difference is these ones are coming in as GeoJSON, but same idea. Features is sent back. We're good to go. All right. So now we've got a database. It's got one layer of data in it, countries. We've got a feature server and a tile server sitting on top of that database. We're going to be doing point-to-point routing in City of Boston. So I'm going to load up some OpenStreetMap data from Boston. Let's see, go to my terminal here. Okay, so this is natural earth. I don't want that. I want the routing data, which is here. There's my Boston OSM data. And I have set up a loading script. Let me just show you what it does. All it does is run OSM to PG routing. So that we're going to read the Boston OSM file. This is just my connection information. So actually, I don't even need to run the script. I'll just copy and paste the command. Zoom, zoom, zoom. This is reading 1 million lines. That's quite a lot of stuff from Boston. Pulling it all in, loading it up. Okay, it's now in the data, now in the database. How can I tell? Well, a bunch of ways. I can look at the database. So there's our OSM ways. We've also got something called ways vertices for PG routing. You can also see that our countries table is there, as one would expect. I'm going to go to the tileserv now, and we can take a look at, there's tileserv. We refresh, you can see the new data that we've loaded in. So here is the ways table. Take a look at that preview. There we go. So these are all the ways we just loaded from the OSM file. I'm going to zoom in. Now, it's worth talking a little bit about the principles of routing. So I've loaded PG routing. I'm going to do a point-to-point routing app. PG routing operates on the principle of node to node. So given a start node and an end node, it will traverse the network and tell you the list of edges that you have to traverse to get from one node to the other. In order to get a node with a click, I'm going to need to write a little utility function that goes from coordinates, because when I click the map, I don't get back a node, I get coordinates. So I'm going to click, it's going to give me some coordinates. I'm going to go back and find the nearest node to those coordinates. And then I'm going to do a second click and do the same thing. Given coordinates, find the nearest node, and then I can pass the two node numbers into PG routing and get a list of edges. The other thing going on here is that you can see this is quite a detailed map, right? And it's got a bunch of things you drive on, right? These guys here. It's also got a bunch of strange extra stuff. Looks like we've got some crosswalks digitized here. So this would be like pedestrian only stuff. We got a whole bunch of paths through Boston Common. Obviously you won't be driving on these. I haven't set up my PG routing example to do drive only. I decided to use every edge and then cost every edge with the length of the edge. So effectively what I'm getting are walking routes. I can walk anywhere there's an edge. My walking speed is constant. I don't go faster on wider paths, unlike say a car. My walking speed is pretty constant, and it's proportional to the edge length. So I can traverse any edge in a time which is proportional to length. So I've used length as my cost. So that'll give me walking directions. I'm not great walking directions because you know, this data also includes things like freeways, which you'd never walk on. So you got to look at this as being a very, very simple routing example, where I really haven't tapped the full power of PG routing, but it's all there under the covers. So let's have a look at the HTML and JavaScript that's going to drive this. So this is a good UI for looking at stuff. It ain't such a good UI for doing anything. It's specific to viewing data in the tile server. So what I've done is I've built a little HTML application here. This is the actual frame we'll be using. I've got some instructions over here. Click once to set a start point and a second time to set an end point, and then it will generate the route for you. Right now nothing will happen because I haven't added the functions that actually connect the clicks to PG featureserv, and I haven't put the PG featureserv function in that connects the HTTP call to PG routing. We're going to do all that, but let's take a quick look in behind here at what's going on with the HTML and JavaScript. So here's the part we just saw, right? We've got a div for the map, where that pretty map was. We've got another div here that has the instructions. So this is just the HTML part, and that's all it is. A little div to hold the instructions and a div to hold the map. Done. Then we've got some constants to start with. I've filled in the server name, so here's the name of the EC2 instance I fired up on AWS in the same data center US West as I fired up my Crunchy Bridge database, so they're nice and close together. Here's the pretty base map. I'm just using a set of raster map tiles that Wikimedia generates based on OSM. Here is a vector layer. So I've taken all the ways that I just showed you in the demo UI, and I've also pulled them into this UI so we can see the actual vector view of the ways. I've used open layers as the client, the web mapping client here, not Mapbox.gl.js. So you can see the syntax for doing things like setting up styles, adding layers, and so on is a little different than it would be in GL.js, but it's the same idea. Add in a layer, give it some styling and coloring. In this case, it's gray with some transparency on it. And then here's sort of the exciting part. This is the click layer. So every time we click on a map, we get one of these guys. It's a red circle with a gray background. And here's the route layer. And the route layer is just a JSON layer. It starts off with nothing in it. It's driven by the route URL, which is made up of the dynamic stuff. The place where we clicked, coordinate 1 the first time, and the place coordinate 2 where we clicked the second time. This gets dynamically updated when I click the second time. So that forces the route to redraw, and that point we get that sort of dynamic look of, oh, I've clicked a second time, and now I see a route. This one's going to be nice in bright red. And then we just bind it all together. Set up a map, transform it to the middle, bind our click action to the act of filling out the route URL with the clicks, and then refreshing that route layer so that it reads the new route off of the URL. That's it. So now we just need to set up our URL and make it live. So the URL is going to live by virtue of being set up as a function in the database. So now I get to go over here. Where's my functions? Here they are. So I need two functions. One function, this is one that will not be seen by the outside world. I called it Boston nearest ID. It takes in a geometry. So this is the coordinate of the click. And then it goes and does a nearest, classic sort of PostGIS nearest neighbor search. Find the nearest node, and then return it as a node ID. Because that's what I need for PG routing. I need a node ID. So I'm going from a geometry where I'm clicking to a node ID, which can be used to drive the routing. And that gets called twice in the actual important function. So I'm going to take this function and I'm going to drop it into my database. Boom. So I got my utility function set up there. I also need the actual functions. This is the one that's going to be called by the outside world. You may recall when I talked about functions in PG featureserv, I said that because PG featureserv functions weren't, from a signature point of view, particularly unique, they needed to live in the PostGIS FTW schema. So let's make sure that schema exists. Good. The parameters need to be named. They are named from lon, from lat, to lon, to lat. If you want to be able to view it in a previewer in PG featureserv, you can if you provide defaults. I've provided some defaults. We've got a type here, and then the return, again, is fully defined with return column names, and return column types. So what we're going to get back is a collection of edges. They'll all have an edge number, and even better, they'll all have geometry. So this is a bit more complex to say the least, but it's not too complex. It still fits on a screen. So I'm going in here, I've clicked, so I've got a from long, from lat, a to long, a to lat. First thing I do is I take those longitudes and latitudes and I convert them into geometries. So take the longitudes, latitudes, convert them to a point, set the S rate to 4326. So now I've got a start and a stop point. I'm going to take those start and stop points. I'm going to use my nearest ID utility function to turn the points into node numbers. And here's the magic. PG Dijkstra function. This is a function that comes from PG routing. So I'm going to be going from a web call through PG featureserv into the database and calling a pretty complex analytical function. This is going to build a Dijkstra shortest path through the graph of the ways in Boston. It's going to go from this node ID to this node ID. It's going to use this as the SQL to generate the edges to be used for the graph. And as you can see, the edge stuff I'm doing here, I'm not doing anything. I'm not filtering away the highways, so it's a walking route. I'm not doing anything fancy with the cost to make it a useful driving route. I'm just using length as the forward and backward cost, and then just taking every edge at source to target node and the unique ID. In order, PG routing will return as a result of this a list of edge numbers, but edge numbers don't make a very nice map. So after we get back from PG Dijkstra the list of edge numbers, we're going to join that back to the ways so that we can get the geometry and draw our map. So that's kind of how it all goes. Get start and end node, turn that using the Dijkstra algorithm into a list of edges, join that list of edges back to the geometries so we get a set of geometries, and return that all as a table value. And PG featureserv will happily turn that into JSON and fire it back to the client so it can show up on the map. So this is really the best part. So this is basically my middleware, right? But I'm not doing any coding in Go. I'm just taking this function and dropping it into my database. And now when I go back to PG featureserv, let's go back to the home and refresh. I now have the Boston find route function in my list of functions, so it's ready. It's available to call. If I view it, I'm not going to see much, but I am going to see the default route. So this is the function actually running in the back end. This web UI is setting back these default parameters, and it's turning over in the back end and returning this route. So great, I'm almost there. I don't know if I need anything else. Let's see. I've got my UI. I've got my functions. I've got my tile server set up. So I've got my base map of ways. Got my base map from Wikimedia. So if I refresh this, I should see, in addition to the Wikimedia base map, I've now got these heavier gray lines. So these are the ways coming back from the tile server. And then I've got HTML JavaScript, so I should be able to click once and get a dot. Great. And if I click a second time, I should get a dot and the route between the dots. And that's how quickly it goes back to the PG routing server and gets the route. So this is doing one server round trip each time, generating a new route each time. Sometimes the routes are weird when you go and play. I think I missed a node. When you go across these bridges, I've found it's less happy, and I haven't figured out precisely why. There's something about the data which doesn't like them. But you can route through the whole thing real quick. And all I've done is download some data, load it into my database, write two functions, one to go from a click to a node, which is a relatively simple nearest neighbor function, and one to wrap up the PG routing amazing algorithm so that I can access it just using a web service call. And then some HTML and JavaScript, which frankly is the most complex part. And that's the way it should be. The hard part in any application like this should be the part where we figure out how is my user going to interact with all this cool functionality, and how am I going to expose it to it? How am I going to make it look nice? It's the UI where the effort should have to be put. The functions that sit in the back end should be easy to expose because all it is plumbing. So the idea of featureserv and tileserv is to provide that lightweight plumbing so you can do something really, quite sophisticated like this, only thinking about how the UI is going to work. Okay, so that's it for the demo. Here's some useful links. The demo application we just showed you is available in the examples directory of the featureserv. So if you're intrigued, go try it out, improve on it. The components of the demo are Crunchy Bridge, the PostGIS software as a service, PG tileserv and PG featureserv, Golang lightweight tile and feature servers available at github.com in open source. OpenLayers.org is the map framework I used to build the application for the front end. PG routing and PostGIS, of course, sitting at the back end, providing that geospatial analytical server side, and underneath it all, rough and ready, postgres.org. My email is paul.ramsey@crunchydata.ca. If you want to get in touch, please drop me a line. Thanks to Steve Pusty for organizing this virtual PostGIS Day, and thanks to you for sharing virtual PostGIS Day with me.
I kind of like the music, and I just want to keep it so I can keep hearing it. I think of when I used to go to drive-in movie theaters when I was a kid. All right. This would be the time when I would go get popcorn.
Exactly.
Exactly. I'm going to stop sharing. Okay. So we're back. Martin has been answering questions in the chat, which you probably saw. And then there was the only things that were said in the Q&A or the chat. I don't think there's any Q&A question. Oh, there are. How do you set it up to run as a service? So it starts up on server reboot, asking for a friend.
Yeah.
That's Regina.
Yeah, of course. So whatever way makes the most sense for you, frankly. It's going to be operating system dependent. If this is the olden days, you'd stick it in rc.local. If it was the slightly newer days, you'd write a init script for it so that you could drop that into etc init.d and you'd run it that way. I'm not sure what the new kids are doing, with systemd and all this fancy stuff, what the right way to wrap an app is now.
The new way to do it is you just put it in Kubernetes as a container.
Well, I was getting there, Steve.
Yeah.
But
Sorry.
And at the end of the day, you can take the container image and throw that into whatever cloud container holder you've got, and that's probably a really nice way to do it, and probably the way most people end up doing it in production. But for the point of view of standing it up and getting it started and so on, a script or fire it up in your terminal when you need it, yeah.
I mean, and that was one of the things that was really amazing about it for me when I first started using it and when we were working on it, is as opposed to downloading this huge binary and then trying to figure out how to start it, setting up all these configuration files, putting in all this, not just like making up a schema, making up a whole bunch of stuff that I had to put in. I just basically download a binary, tell it where the database is, and go. And it's just one command and I'm going. I can actually start working with it right away. And I think that was one of the other parts I really liked about how lightweight it is, right? It also, we've done demos together where we put this in Kubernetes, and the resource consumption, because it's just a little shim, there's almost no resource consumption. It's a couple megs for the server to run. So it really is really quite nice from a developer's perspective as well. Do you want to take some of those?
Is it possible to return nested objects from functions to featureserv? I almost wish Martin was here to take this on. It should be in theory possible, but that involves a certain amount of complex unmarshalling. I would hope that at a minimum we can return arrays. But as things get more nested, don't know.
I don't have any thoughts on it, so.
Yeah, I've not tried. Sorry, we can't give you the for sure answer on that.
So Marat, the short answer of that is no, it does not right now currently. But again, it is an open source project, and it's really simple as long as you just learn a little, some Go, not a little, but some Go, you can start working with Martin's the lead maintainer on featureserv, right? And Paul's the main maintainer on
tileserv. yet another reason why we chose to do 2 instead of 1. It's easier to parcel out the work. Yeah.
Well, and yeah, but I argued that we should have 2 instead of 1 also because sometimes you just need a feature server and you don't want a tile server and you don't want to mess around with the tile server. So I can scale the tile server independently of scaling the feature server, right, which is nice. All right, next one's you.
Would love some thoughts on securing the tile server, and this is true of the feature server as well, actually. So our thoughts are twofold. First of all, we got the question of what can these services see? And what they can see is determined by the role they connect as. So very much the expectation is to push as much of the thought about what objects the system can see down to the database. So use database permissions to control that. So have a user these things connect as and control their visibility by granting select on the tables you want them to see and not on the tables you don't want them to see. In terms of sort of other stuff, like coming to the front end, I've got 100 users. Are they allowed to connect to the feature server? Are they allowed to connect to the tile server? We've been biasing towards the idea of stacking proxies in front of this service. We don't want to build a big security hook into this tiny little service. It makes a lot more sense to stack proxies in front. Same thing actually goes with like caching. One of the first things you notice when you look at a dynamic tile server is it's generating these tiles dynamically, and I don't want to do that every time because they don't change that fast. They change a bit. I want them to be dynamic, but I don't want them, be regenerated every time. How do I fix that? Stick a reverse proxy caching server in front of them. And the same thing goes for access. Stick a proxy access server in front of it. I can't remember the name, but there's one that comes with Keycloak that ties into the Keycloak services.
No, that's a different one. Oh, 3Scale, this 3Scale API gateway.
There's like it's a tiny little piece of software. It's got like a D at the end of it even. Anyways, there's HTTP proxy front ends, and that's how I'd recommend handling that. That way you can have like the same single sign-on that's in front of your web app can be the single sign-on that's called by the proxy in front of the tile server, and they can all hook together and you don't have to think about it in more than one place.
Right.
So
you can also use an API gateway, right? A lot of companies have API gateways where that's tied into their, into their Kerberos server or whatever that's going on. The other thing that we were searching for feedback on, we didn't build it in because it would be a lot to build in at the beginning, but the idea of somehow accepting an, I can't remember the name of the tickets anymore. It's not a OAuth token. It's an open, it's not OAuth, it's the superseder of OAuth, and I can't remember it. But basically allowing you to sign in with something like Google or a central authentication server, and we would accept you would have to set up some sort of permissions or something, and then we would do that. But that's a lot more work. And so we're waiting for someone to actually say, I need that before we actually attempt that. So
yeah, there are a lot of, there's a lot of ways to start up your system and run it, your software and run it as a daemon. There's a hell of a lot of ways to skin the security cat. It's
OpenID. It's not, JWT is in OpenID as well. It's OpenID Connect, right? That's what we were thinking of.
Does your processor spike when looking for the solution? I'm not sure I understand that question. Generally speaking, getting answers requires CPU time. Two things. One, definitely both these services in a production capacity should probably have some sort of cache in front of them so you don't constantly re-hit for the same question or the same tile. But secondarily, either if you're on Crunchy Bridge or you have some other setup for read replicas, if you have a computationally intensive question, being able to read scale your database out. So if you do in fact have load that is not cacheable and is dynamic and you need to service it, being able to spool the backend out horizontally is a way to deal with processor spiking.
Right, but the processor would not spike on the app server. The processor would spike on the database server, because all the app server is doing is basically a translating layer of, I'm going to give you a web request and I'll emit SQL, and then I'll get SQL data results back and give that back to you as JSON.
Yeah, it would be quite hard to spike the middleware CPU because it does so little. Is it possible to reduce vertices or simplify geometries by configuring tileserv? The magical answer is you don't have to. The whole point of, or vector tiles themselves have a fixed resolution. by default, and you can change it, but the default in tileserv is 4,000 by 4,000. So it's a fair amount of resolution, but it's not infinite. And we condition the data before we write it into those tiles so that it has just enough information to show, but not redundant information. So if there are features that are below the resolution size of the tiles, they'll get dropped. If there are vertices that are below the resolution size of the tiles, they'll get dropped. So they already do get simplified and crunched down to fit into the tiles. So you're basically getting the optimal tile. If you want your tiles to be even smaller, you can reduce their resolution. So instead of 4,000 by 4,000, you could cut them down to 1,000 by 1,000. How does the authentication work? Is there a way to set up a layer only for a specific user? No, within one particular service, everything that it can see is what the database user, the backend, can see. If you do want different logins to have different visibility, we've so far recommend establishing just running 2 services and have the different services connect with different users that have different visibilities.
And then control access to those services through your web app.
Exactly. Right? Yeah. And
okay, so there was a question in the Discord about, and I don't know if you have anything set up on your machine, but actually, like, could you serve back a buffered? Could PG featureserv serve back a buffered layer in response?
Yeah, the answer is yes. It would be a function-based layer, but yeah, you'd probably have a parameter for the buffer width, and you just say, show me, and change the buffer width, and it would change the size of things. That's a relatively simple demo to do.
So before PostGIS 3.1 had all those nice tilings built in, Paul had a nice demo where he was actually generating tiles dynamically on the fly through function calls so JavaScript tiles on the fly through function calls to the functions in PostGIS. Into PostGIS had the functions, and then featureserv, or was it tileserv?
I think it was featureserv. Martin's got some wonderful tricks where where you can push the function stuff back. Yeah.
And that's the other thing I think we're taking. Speaking of Martin, the other thing we're thinking about or taking feedback on is also updates. And I don't think OGC spec currently covers editing data. Is that correct? Martin, do you remember? I don't remember, but I know that we're taking feedback on editing and what kind of functionality is needed for editing or inserting records into the table.
Yep. How do I employ row level security with these services? Same answer, really. It's well, it's not great because you have one login per service. So if you want your service to only see certain rows, you would give that service that login, and then using row level security, only let them see the rows you want them to see. Harder if you want different incoming users to see different rows, because then they'd have to swap their connected user, and that's something we haven't set up yet.
Is that it?
I think that is.
Thanks above that. Any last questions for Paul before we wrap up? I think we're going to see our next talk. I think actually will show an example of using. Yes, I think, yeah. Paul, yeah, the next one is actually going to show PG featureserv and PG tileserv in action.
Cool.
So, all right. I'll wait. One new message. Nope. Thanks. These services are neat.
Yeah, I think so too.
Yeah.
So funny thing, last PostGIS day, I gave a talk on vector tile serving, really focused around the functions for doing it inside PostGIS, and then how to write a little script to make it happen. And here we are a year later, and we went from that PostGIS day and said, you know, it would be nice if it was more than a script. And here we are a year later, and it's more than a script. So yeah, tile serving is a big deal. Feature serving is a big deal, and we're really happy to see folks taking up these services.
Yeah, I mean, someone in the Discord said the BC government, British Columbian government teams have PG tileserv running in production on OpenShift, so on Kubernetes, and are pretty happy with it. So
nice.
Yeah. All right, let's. We have to point out the one thing Martin likes to talk about with featureserv. Like, so Martin is so excited about featureserv.
Oh, yes.
Basically, that you don't ever have to write a middleware function again. You can basically write all your functions to come back. You basically have an arbitrary REST server if you want to use featureserv as an arbitrary REST server. So I probably didn't explain it exactly right. So Martin can clarify in Discord, but he loves that
It's
idea.
not just spatial. It's not just spatial. Anything
Anything
you want to ask, you can get a database answer back, and you can have feature server be the thing that mediates that process. So
it'll just give you JSON back. So he and I argue about that all the time, but I like to point it out because he's very proud of it. All right. Thanks, Paul.
Thanks, Steve-O.